The deck of the bridge. The deck must cover the full 26-meter length of the bridge and be at least 4 meters wide to allow pedestrian traffic in both directions. Les Amis de la Gare Sherwood would like the deck to be as wide as possible without going over their $450,000 budget. The deck of the bridge is made of interlocking transparent glass panels in the shape of a rectangular prism with a thickness of 10 centimeters. The glass panels come in varying widths, which are at 1 meter intervals. The volume of the panels used for this deck must not exceed 1/3 of the volume of one of the concrete pillars. The cost to supply and install the glass panels depends on the area of the deck. I found this a bit confusing because I thought they meant the total surface area of the deck, and they don't. They mean the area of the top of the deck. The supplier charges $1,590 per meter squared to supply and install the glass panel. As a member of the engineering team hired by Les Amis de la Gare Sherwood to design the bridge, your task is to determine the largest possible width of the bridge deck. The cost without the glass so far is $194,375. The maximum cost of the glass would be our full budget, take away what we've spent so far, is $255,625. The cost depends on the area of the deck. The deck is 26 meters long times whatever the width is. So I'm going to call the width X. This is a little three-dimensional image of what the deck looks like. It's 26 meters long. It's 10 centimeters thick. Its width, we're not sure of. That's the X. We're going to call this width the X. The area of the deck is 26 times X. The volume is 0.1 times 26 times our unknown X, which is 2.6X. We know the volume has to be less than 1/3 the volume of one of the concrete pillars. One of the concrete pillars is 68.7386 meters cubed. Divide that by 3. Gives us 22.9129. Divide both sides by 2.6. X has to be less than 8.8126 meters. 8 meters wide is the widest it can be. 4 meters wide is the narrowest it can be. So it's got to be somewhere between 4 and 8, including 4 and 8. I'm setting up a proportion. We know that the glass costs $1,590 for every meter squared. We have this much money to spend. How many meters squared can we have? We're spending that much money. The area of the deck, we don't know. This is our proportion. I'm going to cross multiply. I'm going to switch the 1,590 with the area of the deck. And that gives us 255,625 divided by the 1,590. The area of the deck can be 160.7704 meters squared. And the area of the deck is 26x. 26x is equal to that. Divide both sides by 26x. The width can be 6.135 meters squared at a maximum width. But the problem is the deck only comes in intervals of a meter. It can be 6 meters, it can be 5 meters, it can be 4 meters, but it can't be 6.1. X is 6. The width of the deck will be 6 meters wide. 26 times 6 is 156 meters squared, times the $1,590 per meter squared gives us $248,040 for the deck. The total cost is, the cost without the glass, added to the cost of the glass, the $248,040, gives us a grand total of $442,415, which is less than the width of the deck is 6 meters. And that's it for the ES. Have a good day.